Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be talking about Form 1 chemistry. And our topic of discussion today is air and combustion. And our subtopic for the day is active part of air. But the experiment we are going to be looking at today is burning copper in air. So in the previous videos, we discussed on first of all burning candle in air, also to determine the active part of air. We also discussed rusting to determine the active part of air. So for today, we are going to look at the burning for phosphorus, burning copper in air, sorry. And also we are going to look at a few questions in regards to what we are going to discuss. So first of all, we'll start with setting up the experiment. So the first thing that you notice when we determine the amount of air passed over heated copper, we are going to use two syringes. We have syringe Y and syringe Z. And in between, we are going to put a tube that is having some copper granules. And on the edges, you're going to put some cotton wool. This cotton wool is supposed to prevent the copper granules from not moving or escaping when the air is passed through. So, and then the air is pushed from syringe Y to syringe Z, and then it's pushed back again continuously. And then as the air is being passed from syringe Y to syringe Z, the copper turnings are heated strongly. So the copper turnings are heated and the air is being pushed from one syringe to the other continuously. And later on, we will see that it's going to be passed slowly. There's a reason why it is going to be passed slowly. We are going to discuss in our discussion section. And then it's done for several minutes and then the observations were noted. So when we look at some of the observations that we note for this experiment is one of the things that we note is the color change. And you notice in most of our experiments, the color change is the first thing that we note. So the color change on the copper, so copper metal is brown in color. When it reacts with oxygen, it forms a black solid, and the black solid is called copper 2 oxide. So it forms copper 2 oxide. And then also the next thing we'll notice is the mark on the plunger Z. This is where we are going to get the final volume, was noted to be 80 centimeters cubed. And remember, when we are measuring, we are getting the final mark, we need to allow the apparatus to cool, just like we had said in the previous experiment. The reason why we are allowing the apparatus to cool is because they actually expand when they are heated. And you see there's a heating that is continuing in this reaction. So the expansion can give you inaccurate volume. So you need to give the apparatus some time to cool before getting the final volume of the experiment. So why does this color change in this manner? So heated copper reacts with oxygen in air, which is in the apparatus, to form copper 2 oxide. You can see the air is being pushed from syringe Y to syringe Z continuously. And then the reason why we get the 80 centimeters cubed mark is because 20% of the oxygen is used up in this reaction as the air is being passed over heated copper. So what are some of the equations for the reaction? So copper reacts with oxygen to form copper 2 oxide, and this is the equation. Note the colors as we discussed previously. It's turning from brown to black. So for the chemical equation is shown below. And this helps us to conclude that copper utilizes oxygen when it's burnt to form copper 2 oxide products. So if we were to calculate the final calculations, remember we were passing the air from syringe Y to syringe Z. First of all, we were passing it slowly. We are passing it slowly to give it enough time to give the air enough time to come into contact with the copper solid. And then after we allowed the apparatus to cool, we were able to get the final volume. But the final volume was measured on the syringe Z. So we took the initial volume on syringe Z and also the final volume on syringe Z as well. So you take the initial volume, it can be a specific volume in centimeters cubed, and the final volume of syringe Z in centimeters cubed. So the final calculation would be initial minus final, and then the one that was used up, which is gotten from the subtraction, you divide by initial times 100. It's the same formula that we discussed in the previous lesson. So let's do one question in regards to what we have discussed so that we can be able to put into practice the content that we have discussed. In an experiment to determine the proportion of oxygen in air, copper turnings were packed in excess, and you can see they are packed in excess, and then you'll see why, in a combustion tube connected to two syringes. Both of the syringes are 15.6 centimeters cubed, and then so syringe R was the one that was 15 centimeters cubed, and then syringe S was closed and empty as shown. So one syringe has, this syringe has 15.6 centimeters cubed, the other one was closed. So this air is the one that is being moved from one syringe to the other. So the air was passed over heated copper turnings slowly and repeatedly until there was no further change. And then after cooling, 12.4 centimeters cubed of air remained in syringe R. So that's it. We have the setup as shown. You can see we have syringe R and the other syringe S. So air is being moved from syringe R to syringe S continuously and slowly. So let's look at the questions. Why was copper packed in excess? So we are packing copper in excess to ensure all oxygen has reacted. Next question is state one observation made in the combustion tube during the experiment. We said one of the observation is the color change of copper. So we will say that the brown copper turnings turn into black copper oxide or copper 2 oxide. Question C, give an equation for the reaction that took place in the combustion tube. So in this question, we are writing the equation for the reaction between copper and oxygen. So it's copper reacts with oxygen to form copper oxide as the product. Finally, determine the percentage of oxygen used up during the experiment. So we are back in this calculation. So we said the initial, which was 15, it's 15, not 15.6, 15.6 minus final, which was 12.4 centimeters cubed, which gives us the change would be 3.2 centimeters cubed. So we take the 3.2 centimeters cubed over the initial, which was 15.6 centimeters cubed, and then we multiply by 100 because we want it in percentage. So this gives us 20.51%, which is the same as 21% in if you round off to whole number. So that is the calculation for this reaction. I hope you have been able to understand how to use burning copper in air as a way to show the active part of air. So for the next lesson, we are going to do burning of phosphorus in air as well to see how we can get the active part of air when we do that experiment. So see you in the next lesson as we do phosphorus in air.